All right, so before we do anything, I'm gonna just put some video up, which is in here, in here, in here.
It has officially begun. Unitree Robotics has officially launched a robot that you can purchase to go into your own home. Years ahead of schedule. You can buy one of these robots today. 16,000 US dollars. Videos of these robots are going viral everywhere. They're walking the streets of China right now, watering.
Okay, do you get it? Now, let's talk about intelligence. DeepSeek. And I'm asking about Michael Levin and how we might model the emergence of conditioned behavior in a simulated universe of creatures in order to teach evolution and evolutionary biology, behavioral dynamics, population dynamics, and use of AI in programming languages. So, starts off this conversation with 6 slides which look a bit like this. Can I get to see the slide? No, I can't. That was just telling me how much the slide is uploaded. So that's a transcription of, sorry, that is 6 files which are the text of the transcript of a YouTube video. About 30 seconds in each one. So I've captured 3 minutes. And I say, what is he saying here? In other words, the machine has read what is in those pictures. Now, Michael Levin is discussing the concept of embodiment and agency in biological systems, using the example of a bacterium navigating its environment. Here's his key points. Now, then I say, outline an evolutionary game modeling a simple ecosystem where physical space and physiological space and behavioral space are explored simultaneously. So it does that. And then I say, yep, okay, so imagine you are joining a conversation where the game is being designed to explore this space and the game design is being sketched out. So have you got the context here? I'm saying to DeepSeek, well, you're joining a conversation. You're not going to tell me how to do it from word go. Because people are already invested in this game in a collaborative environment. So it comes up with this. It's information flows through agents' integrated decision making, not directly between spaces. Agents individually dynamically weight inputs based on their internal state and so on, is what it says. And I say, well, you were talking about epigenetics, and I didn't see epigenetics listed as one of the possible spaces. I saw the physical world, I saw physiological space as something that the organism can explore, behavioral change as something that it could explore, and so on. So we have a little discussion about how the game works. Then it talks about that, which, you know, if I was to do this slower, this does actually make sense. Full pressure testing of the game and so on. What do I ask next? Yeah, I said you're a little bit obsessed with methylation of gene expression and its role in gene expression. Try to think about it from the point of view of wider game. But we are trying to, I should have said the game is trying to avoid thinking like a bacterium or a liver or even a lion, because that introduces observer bias. Because what we want to do is have a lion that is, or we want to just observe whether or not packs of lions whether or not like collaborative predation emerges or not from an abstract primitive lion to a modern day lion. What kind of behaviors do we see emerging from simple programming rules, extremely simple programming rules? I don't want to say the lion chases after the antelope because it smells it. What I'm saying is Now what we want to do, of course, is make the internal workings of the lion's body-mind complex visible, and this is the challenge. This is the parallel challenge here, is to do the same with an artificial intelligence, make its internal workings visible. So anyway, we were talking about various ways of doing this, and these all make sense. I believe you're right. We're suggesting one big multidimensional space. You don't have to understand what each dimension does. Some dimensions you may, some dimensions you may not. Yeah. And we do get to a language which is very much the language of machine learning. Where signals come from is irrelevant to the agent. Only correlational weight matters. What we've done is we've abstracted urge to move to somewhere where we don't say an urge to move evolves. It emerges from the signals in the environment as a I don't know that I have answered that question, because we've got to up it to a complete. Start with global. S of t is all dimensions. Now once you get into programming like that, a lion is a lion weights are a numpy array, prioritizes prey over toxins. We'll see how the I don't know yet. The weight matrix over generation after generation, the weight matrices of W of agents can evolve. Mutation and selection based on fitness, energy accounted, survival and reproduction. No, I'm going to measure that by population dynamics. I'm not measuring that objectively as a human. I'm saying this is a lion who aggressively hunts and shares food. I might tweak the existence of a lion like that, posit the existence of a lion like that in amongst a population of lions with a statistical yes. Okay, so around a mean figure, each lion has more or less of this particular dimension. That's what we're trying to convey. I'm actually not trying to list the actual dimensions. I just want the game to take place in space and everything else to take place in a intercommunicating multidimensional space. Where life is resonance. Start coding the vector. 10 minutes.